horizontal asymptotes. That is what we're going to look at now. Horizontal asymptotes. And it can be plural. And the easiest way, or the best way to show you how to do a horizontal asymptote is to just show you examples. And so what I'm going to do is, to get this across to you, I'm going to show you 3 examples. And there's only 3 different options or ways to figure out the vertical asymptote. They're all the same, but just the answer at the end is different. So let me show you what I mean. Example 1, find HA, horizontal asymptote. And I'm going to try to fit it all on the board. Hopefully it works. So here's part A. Find the horizontal asymptote of f of x equals 4x squared divided by 2x squared plus 1. So we're given this function f, and I want to find the horizontal asymptote. So what I'm about to show you works every single time on all horizontal asymptote problems. You just have to be able to diagnose the answer once we get there. So what you do is you look at the numerator and the denominator, the top and the bottom. You want to look at the degree of each. So the degree of the top means what is the highest exponent in the top, or the numerator. And then you want to look at what is the degree of the bottom in the denominator. Okay, so the top, its degree is 2. Its highest exponent is 2. Then what's the highest exponent in the bottom? It's 2 also. So if the degree of the top and the degree of the bottom are the same, then you take their coefficients and you divide them. What I mean is, so you literally just, whatever they are, you take them, and that is your horizontal asymptote, 4 divided by 2. So you can say y equals 4 over 2, which is 2. That is, your horizontal asymptote is y equals 2. That's all it is. And graphically, this looks the same as the vertical asymptote, except the horizontal is a dashed line horizontally. And the graph will get closer and closer to that on either end. All right. Now part B. Let's call this function g of x. And what I'm going to do is I'm going to change up just one number here. So on the top we're going to have 4x, and on the bottom is going to be the same, 2x squared plus 1. So again, these problems start exactly the same. You need to determine what the degree at the top is, and then you need to determine what the degree of the bottom is. So the degree of the top is 1, which is not written, but it's 1, and the degree of the bottom is 2. So they're different. And in all the horizontal asymptote problems, we need to make the degree of the top and the degree of the bottom the same thing. So how can we do that? How can we make the degree of the top the same? Pause and think for maybe a minute, however long. So the way you do that is we add in an x squared on the top, but we make its coefficient 0, because 0 times anything is just 0. We're not changing the equation. We're just making it easier for us to perceive what the horizontal asymptote is. So you just do it like this. You can write it kind of above or whatever you need to do, or out to the side like this. 0x squared plus 4x. So now I've made the degree of the top and the degree of the bottom the same. Once they're the same, then the process just repeats over here in A. I take the coefficients, I say y is equal to that, and I divide them. So my coefficients of the x squared terms are 0 divided by 2. So now I say y is equal to 0 divided by 2, which is 0. So that's my HA. horizontal asymptote is y equals 0. Part C. And the last option here. H of x is equal to, let's call it 2x cubed divided by 2x squared plus 1. So the denominator is staying the same through all these examples. All I'm doing is manipulating the top degree. So I look at the degree of the top and the degree of the bottom. And if they're the same, I take the coefficients. If they're not the same, then what do? I make them the same by adding in a 0. So the degree of the top is 3, the degree of the bottom is 2, so they are not the same. That means I need to add a 0 on the bottom here. So 0x cubed plus 2x squared plus 1. Now, I made them the same, and it works exactly like I've done over here. I take the coefficients, so 2 divided by 0. So I say y equals 2 divided by 0, which is undefined, or does not exist, however you want to say it. So that means there is no horizontal asymptote here. So those are our three options. You're going to have an integer number like this if they're already made the same, if the degrees are already the same. If the degrees aren't the same, then you're either going to be 0 or none. All right, and this is how you find the horizontal asymptote every single time. You make, if the degrees are the same, you take their coefficients. If they're not the same, then you make them the same and you take the coefficients anyways.